All right, so we'll take a look at polynomial division in preparation for our summative assessments there next week. We're just going to take a look through this unit test on Khan Academy so that we can understand the concepts that we're going to encounter when we hit our polynomial division summative next week. Okay, so let's go. All right, so first of all, there's two types of division that you want to understand going into your summative. One is just long division. The other is what we call synthetic division. We'll take a look at both of them here. And this is a nice simple problem for us to solve using both. Okay, so we have x squared plus 2, which we're going to divide by x minus 1. We may or may not have a remainder, and if we do, we will put it in the proper form. Okay, so with long division, what we do is we take our x squared plus 2, and we are going to long divide that. We're going to long divide that by x minus 1. Now, with long division, all you ever need to do is divide by the first term in the polynomial, whether it's a longer polynomial or a binomial like this, right? We just need to divide by the first term. So x squared divided by x is x, and x times x is, of course, x squared, and x times negative 1 is negative x. All right, so this brings us back to the first step, and I'm going to rewind a little bit here. So the first step, you'll notice that, well, I don't have any x here to subtract. Well, that's because you forgot to include it, okay? Or I forgot to include it. Okay, so here's what we need to do. All right, we need to take this plus 2, and we need to move it over to the side a little bit, okay? And in that place, we need to put a plus 0x. Let me put our plus 2 in there. Okay, so we need to make sure that our polynomial that we're dividing has a term, has a term for every exponent from the leading exponent, from that highest exponent degree, all the way down. So we had an x squared, we must have an x to the power of 1, right? Of course, there's an invisible x to the power of 0 here, and if the x to the power of 1 does not show, we need to just multiply it times 0 so that it doesn't exist. Okay, now we can proceed. So we're going to subtract right here, and we get 0x minus negative x, which of course is positive x, right? So it's positive x, and we bring down the rest of the equation, okay, or the rest of the expression. So x plus 2 is what we're left with now. So x divided by x is equal to 1. X divided by, and 1 times x minus 1 is, of course, x minus 1. And we subtract that once again, and we'll see we have a remainder. So we have a remainder here of 3. That 3 needs to be put back in with into our solution with a denominator of x minus 1. So it is plus, this is positive 3, 3 over x minus 1. Right? So that's how you solve this with long division, and this idea here flows over to synthetic division. So let's take a look at synthetic division. Here's what it looks like. All right, so I usually make a box. A lot of the time you'll just see somebody do the side, two sides. That's all you really need. The idea here is what we do is we just take the coefficients of our we just take our coefficients of our numerator here. So we've got x squared, there's a coefficient of 1 there. We have a 0, right? Remember we talked about that 0? We've got a plus 0x stuck in there that we need to deal with. So we have a coefficient of 0, and we have a coefficient of 2 in the constant, right? I refer to it as coefficient. It's, of course, 2x to the 0 is what I'm referring to as a coefficient. So it's both a coefficient and a constant. Okay. So the next thing I do with synthetic division is I need to take a look at my denominator here, and I take this binomial and I take the second term, the constant term. I change the sign on it. So change the sign, and I just pop it right over here. So it's a positive 1. All right. I'm going to use that as a multiplier as I go along. Okay. So pop down here with the 1, multiply this 1 times 1, and it goes right up here. Okay, add these two together, I get 1, and multiply 1 times 1 again, and put your solution right here. Add these two together, and there's your remainder right here, and we'll see our coefficients. We reduce our coefficient by 1, and we get 1x and then we get plus 1, so x to the 0, of course, and then we've got plus, this is our remainder, our last term in our synthetic division will always be a remainder, so that's 3 over x minus 1. Right? So that's what we're looking for in terms of basic division for dividing polynomials. Let's move on and do a few more. So we've got x plus 1 plus 3 over x minus 1. And there we go. All right, so here is another type of problem that you will certainly see in the division and possibly in the factoring assessment as well. This polynomial here has a known factor of x minus 2, which means you can divide it cleanly with no remainder by x minus 2. Let's see how we do that. I'm going to use long division to do this. That's my go-to. I like long division, so that's what I'm going to do. Double check that we've got all our exponents. 3, 2, 1, 0. Boom. And we're ready to go. Okay, so we've got 3x cubed minus 5x squared minus 4x and plus 4. Okay, and we are going to use long division. I'll set that right up here. Long division, and we're going to divide by x minus 2. No need to change the change anything in the divisor when you're using long division. Okay, 3x cubed divided by x is 3x squared, and 3x squared, of course, times x is 3x cubed as expected. 3x squared times negative 2 is negative 6x squared, and you can see how everything lines up nicely here. So we're going to subtract all of this. That's fine. This is negative 5x minus negative 6x is positive x squared. Of course, x squared is what I'm talking about here. And bring down our negative 4x. Okay, so let's do it all over again. X squared divided by x is x. So we got plus x here. And x times x is x squared. X times negative 2 is negative 2x. And we subtract once again, and we get ourselves, well, we're adding a 2 here. So this is a negative 2x. Okay, good. All right, so once again, bring down this, we just brought those down, bring down this positive 4. And we get ourselves, well, negative 2x divided by x is negative 2. And negative 2 multiplies in here nice and tidily. Negative 2x, negative 2 times negative 2 is positive 4, and we notice we have 0 remainder, so that is nice. Okay, let's break up our factors, because we're not quite done yet. That was just the division part. Let's set up the factors. So we know we have a factor of x minus 2, so let's plug that in right away, x minus 2, and our remaining factor is a quadratic. Let's take a look at this. We've got a quadratic here of 3x squared plus x minus 2. Okay, so I want to do this by grouping, and I'm not entirely pleased at how this looks here. So what I'm going to do is I'm going to notice that I have a 3x squared here. Well, the 3 is going to be instrumental, okay? So what I'm going to do here is I'm going to break this up a little bit. I'm going to say this is 3x squared plus 3x, okay? So I've just added 2 more x's here, so I need to subtract them as well. So I'm going to subtract 2x as well, okay? And then I get minus 2, okay? So all I did here is a nice little trick. I just kind of uncombined like terms, if you like, okay? So I noticed that I had a leading coefficient here. I don't want to have a leading coefficient, but I need to deal with it, okay? So I need to deal with a leading coefficient, so I'm kind of going to borrow a 3 so that I have the same coefficient for both, and I'll be able to group those together. So don't forget to bring down your x minus 2. That's still part of what you're dealing with here. And now we can start grouping things together. Okay, so we're going to group each part of this together separately. Okay, and what we will see is we now have a 3x as a common factor of this one here. So I'm going to keep this inside parentheses, x minus 2. And we've got bigger parentheses here. So we've got a 3x as a common factor. So we're going to take out the 3x, and inside those parentheses, then we've got an x plus 1. Okay, and on this side here, right, we've got a we notice we've got a 2x and a 2, right? And we want a plus 1 again, right? We want a plus 1, so we're going to want to be able to change this sign here. So we're going to manipulate this sign here as well as we go with it, okay? So what we're going to pull out here is we're going to pull out the negative 2, okay? So we're pulling out the negative 2 as our outside coefficient, and then we've got negative 2 times x is negative 2x, and negative 2 times negative 2 is positive. So then, sorry, the negative 2 divided by negative 2 is positive 1. So that's where we get our positive 1 from. And don't forget, got a double nested parentheses there. But we'll deal with that right now as we go along. Inside these parentheses, what's going on now is we've broken this up. We've got an x plus 1, which is nice, and we've got a 3x minus 2. So let's deal with that first. 3x minus 2 is our first set, and then our second set is x plus 1. And of course, now we can get rid of those other parentheses. They're no longer required, right? I'll get rid of them right here. They're no longer required. And outside, we still have our x minus 2. So this is fully factored, okay? And that's all there is to that, okay? So a few steps on that one there. It's a longer type of problem, right? X minus 2, but if you're asked to find a product of linear factors, right, that is one of the ways of doing it. There's a few other ways depending on what you encounter, right? Depending on what you encounter. The first step in these problems is always to do some sort of division, either synthetic or long, whichever you prefer. But from there, you're going to have to employ something. What you saw here is we expanded this out first of all, then we factored by grouping, and then we put it all together and we were done. Okay, let's take a look at another problem here. This is another division problem, and these ones are a little easier. We'll throw this together very easily. This one here, we don't have a lot of work to do on this because our divisor is just a single x. So all we got to do is basically factor out an x out of each term, and we get, so 4x cubed divided by x is 3x squared, and negative 3x divided by x is negative 3, and 1 divided by x is simply 1 over x. So we do have we've a remainder of 1 there, but we write it as 1 over x. So that's all we need to do for that type of problem. It's a simpler problem. You notice that your denominator in that fraction is a lot smaller and a lot easier to handle. Okay, moving on. All right, we've got a few. Of course, I made a little error right there. I'm not going to change this in the video. I actually made a little error there. Accidentally put in a 3 here. So there's a little mistake for you. I'm not going to change the video. It's just simply a transcribing error there, and we're okay with that. Okay, so it's supposed to be a 4x squared, not a 3x squared right here. Just let's fix that. There's a 4x squared, and we'll be happy with that. And let's move on. All right. We don't ruin an entire video or something like that. Okay, this one here, I'm going to use long division. Again, long division is my go-to if you like synthetic division. Check out my video on synthetic division. Okay, but I prefer long division because in my mind, long division is actually division, whereas synthetic division, no division is occurring. Okay, so to me, that's kind of problematic. And if you're learning how to divide, you should learn how to divide. So I strongly encourage you to go with long division rather than trying to just scramble your way through with something that isn't actually division. Okay, so x minus 2 is our divisor here, so we're just dividing by x. So x cubed divided by x is x squared, and so x squared times x is x cubed, right? X squared times negative 2 is negative 2x squared. Okay, we subtract, right, and we get, that's like adding, right? So these cancel out, these ones here, we get, that's, so now we've got 8x squared because 6x minus negative, so it's positive. Okay, we bring down our negative 5x and we go from there. So 8x squared divided by x is 8x, right? And 8x times x is, of course, 8x squared. And 8x times negative 2 is negative 16x. All right, and once again we divide, right? Or once again we subtract rather, right? Negative 16x. So we've got a subtracting a negative here from 15. We're actually adding, so we get ourselves a nice 11x right here. Now, notice we had nothing else going on here, but we do actually have some stuff going on here that we need to deal with. So we actually have a plus, we have a plus 0 here, if you like, right, that we can drag down. And you'll see why we do the plus 0 just in just a second. So once again, we can actually divide this. 11x divided by x is simply 11, so we're going to put in the plus 11 right there. It does divide nicely, right? So multiplying that in, we get 11x, which can subtract, and multiplying in this 11 times negative 2, we get negative 22, and we notice that now we actually do have a remainder of positive 22, all right? So we have a remainder of 22, which means that that's plus 22 over x minus 2. And that's the reason why we had to bring down this extra 0, which is something that is possible. It's the same kind of principle as making sure that all your x's are within the problem. Okay, so this one here had a remainder. This one is a nice long one for us to look at, and probably a little bit more like the ones that we will encounter in our summative. Over x minus 2, and hopefully I didn't do any computation errors. I don't believe I did. I did some computation errors, and now my video is ruined. Okay, where did I make a computation error? I did. There it is. Okay, accidentally wrote 11 instead of 22. There we go. Okay, so I do that quite a bit. Hopefully you don't do that, but there you go. I'm not going to, I'll see if I can cut that part out of the video, or maybe not. Maybe I'll just leave it as it is. Here we go. Let's keep going, right? There's not a lot of time to be making a lot of videos, so I'm just going to keep on trucking with this. And here we go. Select all the polynomials that have x minus 3 as a factor. So how does this work? X minus 3 as a factor. Well, Here we're going to apply the polynomial remainder theorem. So the polynomial remainder theorem tells you that if you plug in the inverse of the second term in the binomial, right? Okay, if we plug in, so in this case, if we plug in 3 instead of negative 3, if we plug it in for x in each one, right? It will give us, it'll tell us what the remainder is for that polynomial, and of course, if it has x minus 3 as a factor, it's going to have a remainder of 0. So let's try that out. Okay, so if we plug in 3 here, and 3 here, that's going to give us that's going to give us 3 cubed minus 2 times 3 squared minus 4 times 3 plus 3. So that there is 27 minus, there's 18 minus 18, and there's minus 12 plus 3. So 27 minus 18 is 9, right? So 27 minus 18 is 9, minus 12 is negative 3, plus 3 equals 0. So this one here is the one we're looking for, or it's one of the ones we're looking for, right? So let's try the next one. Select all that apply. In this case, in your case, it'll only be 1 usually. Okay, so we'll work it out. So plug in 3 again as a factor, see if it works. 3, 3, 3, and 3. So we get 27 plus 3 times 9 is 27, right? Minus 2 times 3 is 6, minus 6. Right, so you can see here right away that's definitely not equal to 0. So this is not a choice. Okay, we don't need to work that out to see it. Okay, again, plug in again. So we get 3 to the power of 4. All right, so that's 27 times 3, which is 81. Okay, minus 2 times 3 to the power of 3. So that's 27 times 2, which is 54. Right, minus 54 minus 27. Okay, and interesting thing there, notice that was 27 times 2 that we worked on here. We know that 81 is 3 times 27, so we do know that this is equal to 0. So this is indeed an option, right? All right, okay, there we go. This one here is, once again, we've got x to the 4, so it's 81 minus 20 times 3, so that one there is 60, minus 21, and once again, that's one that's going to work for us, right? So the idea here is if when you plug in the inverse, right, so it's got to be, you plug in, change the sign on it, and we're looking at 3, right? If you plug that in instead of x and solve for that variable, right, so you solve a of 3 and b of 3 and c of 3 and d of 3, you solve those out, it gives you the remainder. For it to be a factor, it must have a remainder of 0. So that's where we're just using the polynomial theorem, the polynomial remainder theorem to solve that. Okay. Moving on. Okay. So we've got this polynomial here, right? And we don't know what the k is, right? Once again, this is a polynomial remainder theorem question. So the idea, and I'll show you why. The idea is that if you divide by this binomial x minus 1, you're going to have a remainder of 0, okay? So it's telling you there will be a remainder of 0 if we do that, okay? So we use the polynomial remainder theorem. So we plug in 1, the inverse, of course. We plug in the inverse 1, right? We plug that in for x, right? So we solve p of 1, okay? First step is we solve p of 1. So p of 1 is equal to 1 to the power of 4 minus 2 times 1 to the power of 3 plus k times 1, right? We'll leave k in there, and then minus 4, right? So that's the first thing we do, okay? So let's solve that. That's 1 minus 2 plus k minus 4, and keep on going with that. 1 minus 2 is negative 1, minus 4 is negative 5, so we've got k minus 5. Right, so p of 1 is k minus 5, right? So now what we're told is that this has a remainder of 0, right? So k minus 5 has a remainder of 0, so we say, okay, well, this is equal to 0, okay? It has to be equal to 0 because there's a remainder of 0. That's the way we solved it, okay? So now we solve for k, right? So we add 5 to both sides, inverse operations, and therefore we now have k equals 5. And so for k equals 5, right, for k equals 5, this polynomial will have a remainder of 0 when you divide it by x minus 1. And I encourage you, pause the video, do some long division, practice it out, and you'll see that when you substitute k for 5, this will indeed have a remainder of 0. Okay. All right, 3 more to go. Okay, so another one where the polynomial is a known factor. These are good ones to practice. Okay, so let's look at this. Watch out here. We've got a missing x squared right there. So a 0x squared. So let's long divide it first of all. X cubed plus 0x squared minus 21x minus 20. We're going to divide that by x minus 5. So let's do this quickly. Okay, so this one here is x squared, and x squared times negative 5x is negative 5x squared. We subtract, we get 5x squared. We bring down our negative 21x, and we do it again. Okay, so this is 5x squared divided by x is 5x, and we've got 5x squared, and 5x times negative, that one there is a negative 25x. Okay, subtract again, and we get ourselves 4x, and we bring down our negative 20, and we do it again, 4x, so that's a positive 4, and we notice here now we get 4x minus 20. Right, as expected, should have a remainder of 0 because it has a known factor, is what it said. So here's our quadratic that we're going to work with. Okay. And this one is considerably easier than the previous one that we worked at. So we have factors x minus 5 is our first factor, that's the known factor, and our other factor here is a quadratic factor. It's x squared plus 5x plus 4, and of course this has a leading coefficient of 1, so it makes it a lot easier for us to solve this factor. Okay, so we've got x minus 5 is one factor. The other one here is, well, what are the multiples of 4 that add up to 5? All addition. We're looking at 4 and 1. So we've got x plus 4 and x plus 1, and we are done. Okay, and that's all there is to that one. That's your quadratic factoring. If you need to brush up on quadratic factoring, go back to your unit in Algebra 2A and work on that, because that's stuff that you need. Remember, okay? Everything you learn in math is something that you're going to learn, that you're going to use later on. Okay, so get used to it. All right. I don't mean to be, to kind of say, oh, get used to it. But what I mean is that it's a fact. So just kind of get used to it, as in get better at it, like work on it, make sure that you know your stuff, because you're going to need to use it later on. Practice, practice, practice. Okay, so this one is easier. Okay, so we've got, all we're doing is dividing each term by x. So we'll be able to do this without the pen. Right, this one here is x cubed plus 2x, plus 2x minus 5 over x. Right, so that's there. You notice there's a missing the cube right there, but that's it doesn't matter in this type of division because it's going to disappear anyway. Okay, one last question in here and we'll be done. All right. So we're told here that we have a polynomial, and this is a nice, interesting problem. We're told here that we've got a polynomial. When it's divided by this binomial x minus 9, it has a remainder of 1. When it's divided by this, it has a remainder of 7, and so on and so forth. Right? Find the following values of p of x. So what are the values of and there's only 2 of them here. But the idea here is, do you know the polynomial remainder theorem? Remember, the polynomial remainder theorem tells you, right, that your remainder is given by solving the inverse of whatever is the second term in the binomial. So when for example, this one here is p of 9, right? Okay, this is solving p of 9 will give you a remainder of 1. P of 9 equals 1. This one here tells you that p of 4, so changing the sign, equals 7. This one here tells you that p of negative 4 is equal to 0. And this one here tells you that p of negative 9 equals negative 5. So we've got everything we need right here. Actually, right here, though, these two right here, not this one, this one here and this one here are the 2 that we need. And we go with that. So p of 4 is 7, p of negative 9 is negative 5. It's all given to you. The whole idea is, do you know the polynomial remainder theorem? That's all I have for you for today. If you've got any comments, please leave them in the section below. Again, like I said in the previous video, and it's kind of useful to see a few mistakes through a video because you see what kind of happens. You get your report at the end of doing this unit test, and you see, oh, you know what? I need to brush up on dividing polynomials by linear expressions, right? So when you click on done, at the end of that unit test, you click on done, you can actually scroll down. You can scroll down, divide polynomials by linear expressions. You can try it again. You can practice it. You can watch a few videos if you need it, and you can be sure that you will be well prepared for the summit of next week. Good luck.